Hello everyone, welcome back to our Python programming for beginners course. I am delighted to have you join me once again on this exciting journey into the world of programming. In our previous lectures, we learned what is Python, why it is one of the most popular programming language in the world, and how to write our very first Python program. Today, we are going to explore one of the most important building blocks for programming, variables and data types. Whenever we write a computer program, we need a way to store information. For example, we may want to store a student's name, age, marks, a medicine's dosage, a patient's body temperature, or whether a laboratory test results if positive or negative. Python allows us to store all this information using something called variables. But not all information is the same. A person's age is a number. A body temperature contains decimal values. A name is text. And a condition such as passed or failed can be represented using only true or false. To handle these different kinds of information, Python uses data types. In this lecture, we will learn what variables are, why variables are important, what data types are: integer data type, float data type, string data type, Boolean data type. And finally, we will see practical examples of how these concepts are used in Python programs. By the end of this lecture, you will be able to create your own variables and identify different data types with confidence. So let's begin our journey into Python variables and data types in this lecture. Before learning about different data types, let us first understand what exactly a variable is and why program uses variables in every Python program. Now, let's understand what a variable is. In Python, a variable is a named location used to store data in the computer's memory. Think of a variable as a container or a box that can hold information. In the illustration shown here, the box is named stock price and the value stored inside it is 224.61. Whenever we use the name stock price, Python remembers and retrieves the value stored in that container. This allows us to store information once and use it many times throughout our program. Assigned operator. To store a value in a variable, Python uses the assignment operator, which is the equal sign. Consider the example: stock price is equal to 224.61. Here, Python reads the statement from right to left. The value 224.61 is assigned to the variable named stock price. It is important to remember that in Python, the equal sign does not always mean mathematically equality. Instead, it often means assign this value to this variable. Dynamic typing. One of the advantages of Python is its simplicity. Unlike many other programming languages, Python does not require us to declare the data type before creating a variable. For example, again, stock price is equal to 224.61. Python automatically recognizes that 224.61 is a decimal number and assigns the appropriate data type. This feature is called dynamic typing. In simple terms, Python determines the data type automatically when a value is assigned. Variable naming rules. When creating variables, we must follow some naming rules. A variable name can start with a letter or a underscore. It cannot start with a number. Variable names cannot contain spaces. Python is always case sensitive. For example, age in small letters, age in sentence case, age, all in capital letters, are treated as three different variable names. To make programs easier to read, always choose meaningful names such as student underscore name, all in small letters, drug underscore name, all in small letters, patient underscore age, stock underscore price. Instead of short and unclear names, it is better to use full name separated by an underscore, all in small letters. So, a variable is simply a named container used to store information in memory. We use the assignment operator to place value inside the variable, and Python automatically determines the data type of the stored value. Now that we understand what variables are, let's move on and explore the different types of data that variables can store in Python. Since variables can store different kinds of information, the next question is, how does Python distinguish between numbers, text, and logical values? The answer lies in data types. Let's explore these data types in the next slide. Friends, in Python, there are many data types available. However, as beginners, we will first focus on the four most commonly used and most important data types. These are often called the core primitive data types. They are integer, presented as int, float, represented as float in small letters, obviously, string, represented as str, and boolean, represented as bool. Each data type is designed to store a specific kind of information. Let's understand them briefly. The first data type is integer or int. Integers are used to store whole numbers without any decimal point. Examples include a student's age, number of tablets prescribed, number of patients enrolled in a study, or marks obtained in an examination as a whole number. Values such as 10, 25, 100, and negative numbers like -5 are all integers. The second data type is float. Float stands for floating point number. These are numbers that contain decimal values. Examples include body temperature, blood glucose levels, pH values, body weight, and drug concentrations. Values such as 37.5, 98.6, 7.4, and 65.8 are examples of float data. The third data type is string, represented by str. Strings are used to store text or characters. Examples include a patient's name, a medicine name, a hospital name, or any descriptive information. Strings are usually enclosed within quotation marks. For example, inside quotation Python, inside quotation paracetamol, inside quotation Anita are all strings. The fourth data type is Boolean, represented by bool. Boolean values can have only two possible states, true or false. These values are commonly used when making decisions in a program. For example, a student has passed the examination, a medicine is available in stock, a patient is eligible for treatment. Such conditions can be represented using Boolean values. These four data types form the foundation of Python programming. Once you understand how to use integers, floats, strings, and booleans, you will be able to create and manipulate most of the data encountered in beginner level Python programs. In the next few slides, we will study each of these data types in detail, beginning with the integer data type. Let's start with the integer data type and see how Python stores and works with whole numbers. Let us now begin with the first Python data type called the integer. An integer represented as int in Python is used to store whole numbers. Whole numbers do not contain any decimal point. I repeat, integer do not contain any decimal points. I repeat again, whole numbers do not contain any decimal points. Examples of integers include 10, 25, 100, 1000, and even negative values such as -5 or -100. Integers are among the most commonly used data types in programming. In real world applications, integers can be used to store information such as a student's age, the number of patients in a clinical study, the number of tablets prescribed, the quantity of medicines in stock, or the total marks obtained in an examination. Let's look at the example shown on the screen. A is equal to 10, B is equal to 3. Here we have created two integer variables. The variable A stores the value 10. The variable B stores the value 3. Since both values are whole numbers, Python automatically identifies them as integers. Now let's perform some operations using these integer values. Addition. A plus B. This adds the two values together. The result will be 13. Addition is one of the most basic arithmetic operations in programming. Floor division. Next we have A double slash B. The double forward slash represents floor division. Floor division divides two numbers and return only the whole number part of the result. 10 divided by 3 is approximately 3.33. However, floor division removes the decimal portion and returns only 3. Now, modulus operator. Now consider A divided by B. This is called the modulus operator. It returns the remainder after division. When 10 divided by 3, the quotient is 3 and the remainder is 1. Therefore, 10 divided by 3 is equal to 1. The modulus operator is very useful when checking whether a number is even or odd. Finally, we have A double asterisk B. The double asterisk represents exponentiation or raising a number to a power. This means 10 raised to the power of 3, which is equal to 1000. Exponentiation is widely used in scientific calculations, data analysis, and mathematical modeling. In the previous slide, we learned that integers are used to store whole numbers. However, many real world measurements are not whole numbers. For example, you take body temperature. It may be around 37.5 degrees Celsius. Blood glucose may be 98.6 milligrams per deciliter, and a person's weight may be 65.8 kilograms. To store such values, Python uses the float data type. The word float stands for floating point number. A float represents numbers that contain a decimal point or fractional part. Examples include 3.14, 10.5, 98.6, 65.8, 0.25. All of these values are stored as float data types in Python. Let's look at the examples shown on the screen. X is equal to 10.5, Y is equal to 3.2. Here, Both values contain decimal points. Therefore, Python automatically identifies them as floating point numbers. Now, let's perform some calculations using these float values. X divided by y. This divides 10.5 by 3.2. The result is approximately 3.28125. Notice that unlike floor division used with integers, normal division preserves the decimal portion of the answer. This allows us to obtain more accurate results. Next, consider x asterisk y. This multiplies the two values together. The result is 33.6. Float arithmetic is commonly used in scientific calculation where precision is important. Why floats are important? Floats are widely used in pharmacy and life sciences. For example, we may store a patient's body temperature, blood pressure measurements, drug concentrations, body weight, laboratory values, pH measurements, reaction rates, and many other scientific observations. Because these measurements often contain decimal values, float data types are essential. Floating point precision. This is one important concept to understand about floats. Computers store decimal numbers using binary representations. As a result, some decimal values cannot always be represented perfectly in memory. This may occasionally lead to very small rounding differences. For example, calculations involving many decimal values may produce results that differ by a tiny fraction from the expected answer. For most beginner programs, this is not a concern. However, it is useful to know that floating point arithmetic may sometimes involve small precision limitations. So far, we have worked with numbers, but computers also need to store words, names, and sentences. To handle text data, Python provides another important data type called string. So far, we have learned how Python stores numbers using integers and floats. But what if we want to store text? For example, a patient's name, a medicine name, a hospital name, or even a complete sentence. To store textual information, Python uses the string data type represented as str. A string is simply a sentence of characters enclosed within quotation marks. These quotation marks can be single quotes, double quotes, or even triple quotes. Python don't cares. For example, name is equal to inside quotation mark Naresh. Drug is equal to inside quotation mark paracetamol. Here, both values are considered strings because they contain text. Let's look at the example shown on the screen. The word hello is stored as a string. One interesting feature of strings is that Python allows us to access individual characters using something called indexing. Python starts counting from 0. This means H is at position 0, E is at position 1, L is at position 2. The next L is at position 3 and O is at position 4. This numbering system is called indexing. Accessing individual characters. Suppose we have str1 is equal to inside quotation mark hello. If we write str1 in the bracket 1, Python retrieves the letter located at index 1. The result is E. Remember, indexing always begins with 0. This is an important concept that beginners should practice frequently. String slicing. Python also allows us to extract multiple characters at once using a technique called slicing. Consider str1 in squared bracket inside 1 is to 4. This means starts from index 1, continues until index 4, but do not include index 4 itself. Therefore, Python extracts ELL. This operation is known as string slicing. Slicing is very useful when working with large pieces of text and extracting specific portion of information. Repeating strings. Strings can also be repeated using the multiplication operator. For example, str1 asterisk 3. Since str1 contains the word hello, Python repeats it 3 times. The output becomes hello, hello, hello. This demonstrates that strings support several useful operations beyond simple storage of text. String immutability. Another important property of strings is that they are immutable. Immutable means that once a string is created, its individual characters cannot be directly changed in memory. If we want a modified version, Python creates a new string rather than altering the existing one. As beginners, you don't need to worry too much about this concept right now. Just remember that strings are designed to protect text data from accidental modification. Real world examples. Strings are used extensively in pharmacy, healthcare, and scientific applications. For example, patient underscore name is equal to inside quotation mark Ravi Kumar. Drug underscore name is equal to paracetamol. Hospital is equal to inside quotation mark city hospital. Blood group is equal to inside quotation mark O positive. All of these values are stored as strings because they represent text. The key takeaways from this slide are: a string is used to store text data. Strings are enclosed within quotation marks. Python uses indexing to access individual characters. Python uses slicing to extract portions of the text. Strings are one of the most commonly used data types in programming. We have now learned how Python stores numbers and text. Next, let's explore a special data type that stores only two possible values, true or false. This data type is called Boolean. So far, we have learned three important data types in Python: integers for whole numbers, floats for decimal numbers, and strings for text. Now let's explore another fundamental data type called Boolean, represented as bool. A Boolean value can have only two possible states, true or false. Notice that the first letter must be capitalized. In Python, true and false are special keywords and are not written in quotation marks. Think about everyday situations. A student either passes or fails an examination. A medicine is either available or unavailable. A patient is either eligible or not eligible for a treatment. Many real world decisions can be represented using only two possible outcomes. This is exactly where Boolean values become useful. Let's look at some examples. Is student is equal to true. Is logged in is equal to false. Medicine available is equal to true. In each case, the variable stores either a true value or a false value. Python uses these Boolean values whenever it needs to make decisions. Why are Booleans are important? Booleans form the foundation of conditional statements. Conditional statements allow a program to choose different actions depending on a condition. For example, temperature is greater than 37. If the condition is satisfied, Python returns true. Otherwise, it returns false. This ability to evaluate conditions is what makes programs intelligent and interactive. Truth testing in Python. Python can also determine whether certain values should be treated as true or false. This process is called truth testing. Some values are automatically considered false. Examples include 0, 0.1, quotation marks, square bracket, none. These are often called falsy values. Almost everything else treated as true. For example, 10, 3.14 inside quotation Python in the square bracket 1 comma 2 comma 3. All of these evaluate to true because they contain meaningful data. Real world pharmacy examples. Consider the following variables. Patient registered, true. Drug in stock, false. Prescription valid, true. These Boolean values can help a pharmacy management system make decisions automatically. For example, if a medicine is not in stock, the system may display a warning. If your prescription is valid, the dispensing process can continue. This demonstrates how Boolean values are used in practical applications. The key takeaways from this slide are Boolean data types store only two values, true and false. Booleans are used for decision making and logical operations. They form the basis of conditions, comparisons, and program control. Now that we have learned the four core Python data types integer, float, string, and boolean, let's see how Python can identify the data types of any variable using the built in type bracket function. All of these evaluate to true because they contain meaningful data. Real world pharmacy examples. Consider the following variables. Patient registered, true. Drug in stock, false. Prescription valid, true. These Boolean values can help a pharmacy management system make decisions automatically. For example, if a medicine is not in stock, the system may display a warning. If your prescription is valid, the dispensing process can continue. This demonstrates how Boolean values are used in practical applications. In the previous slide, we learned that Boolean values can be either true or false. But in real world situations, we often need to evaluate multiple conditions at the same time. For example, a student must have both sufficient attendance and passing marks to be eligible for an examination. A patient may qualify for a treatment if either one of several criteria is satisfied. To handle such situations, Python provides logical operators. The three most important logical operators are and, are, not. These operators help us combine or modify Boolean values. The AND operator. Let's start with the AND operator. The AND operator returns true only when both conditions are true. If even one condition is false, the result becomes false. Think of it like a security gate with two locks. Both locks must be opened before access is granted. For example, true and true returns true. However, true and false returns false because one of the condition is not satisfied. Let's see one pharmacy example. Imagine a pharmacy management system. A medicine can be dispensed only if the prescription is valid and the medicine is available in stock. Both conditions must be true. If either condition becomes false, the medicine cannot be dispensed. Next, the OR operator. Let's look at the OR operator. The OR operator returns true if at least one condition is true. Only when all conditions are false does the result become false. For example, true or false returns true because one condition is already true. Similarly, false or true also returns true. Let's look at a real world example. Suppose a student can qualify for a scholarship if they have excellent academic performance or outstanding achievements in sports. Only one condition needs to be satisfied, therefore, the result can be still true. The NOT operator. The third logical operator is NOT. The NOT operator simply reverses a Boolean value. If the value is true, it becomes false. If the value is false, it becomes true. For example, not true returns false and not false returns true. Let's look at the example here in this slide. Print in curved bracket true and false. Since one condition is false, the output becomes false. Now consider print not 10 greater than 5. First, Python evaluates whether 10 is greater than 5, which is true. So obviously the Python returns true. Then the not operator reverses it. Therefore, the final output becomes false. In Python, why logical operators matter? Logical operators are essential because they allow programs to make intelligent decisions. They are widely used in login systems, eligibility checks, medical diagnosis software, inventory management systems, online shopping platforms, and virtually every real world application. As your Python skills grow, you will use logical operators very frequently. So, the key takeaways from this slide are and both conditions must be true, or at least one condition must be true, not reverses the Boolean value. These operators help Python make decisions based on multiple conditions. Now that we have learned the four core data types and the logical operators used in Boolean values, let's see how Python can identify the data type of any variable using built-in type function. Now that we have learned the four core data types and the logical operators used in Boolean values, let's see how Python can identify the data type of any variable using built-in type function. So far, we have learned about the four core Python data types, which include integer, float, string, and boolean. However, there are situations where we need to convert one data type into another. This process is called type conversion or typecasting. Typecasting allows us to change the data type of a value using Python's built-in functions. This is particularly useful when working with user input because values entered by users are usually received as strings. Imagine a user enters the number 123. Although it looks like a number, Python may treat it as text if it is enclosed within quotation marks. For example, inside quotation mark 123, this is a string, not an integer. If we want to perform a mathematical calculation with this value, we must first convert it into a numeric data type. Converting string to integer. Python provides the int curved bracket function. Consider the example int inside the bracket quotation mark 123. Python converts the string 123 into the integer value, which is 123. Notice that the quotation marks disappear because the value is no longer text. It is now a number that can be used in calculations. Converting string to float. Similarly, Python provides float square bracket function. For example, float inside the bracket quotation 123, the output becomes 123.0. Now Python stores the value as a floating point number. This is useful when dealing with the decimal values such as body temperature, drug concentration, or laboratory measurements. Converting integer to string. Sometimes we need to perform the opposite conversion. Python provides the str square bracket function. For example, str in the bracket 123, the output becomes inside quotation mark 123. Now the value is stored as a text. This, conver- this conversion is often used when displaying message or combining numbers with strings. Now converting numbers to Boolean values. Python also provides the bool curved bracket function. For example, bool inside bracket 1 returns true because non-zero values are considered true. Similarly, bool bracket inside 0 returns false because 0 is treated as false here. Let's look at a real world example. Suppose a user enters their age. Age is equal to inside quotation mark 21. At this stage, age is stored as a string. If we want to calculate age plus 5, Python will produce an error because strings cannot be directly added to numbers. To solve this problem, we convert the string into an integer. Age is equal to int in curved bracket inside age. Now, Python can perform mathematical calculations successfully. You need to remember one important note here. Type conversion works only when the value is compatible with the target data type. For example, int inside the bracket quotation mark 123 works perfectly. However, int inside bracket inside quotation hello will generate an error because the word hello cannot be converted into a number. Therefore, always ensure that the value can be converted before performing typecasting. Now that we have explored variables, data types, Boolean logic, and type conversion, let's bring everything together and see how these concepts work in a complete Python program. We have now reached the end of today's lecture. Let's take a moment to review the four fundamental Python data types that we learned today. These data types form the foundation of almost every Python program you will write in the near future. Integer, int. The first data type is integer, presented as int. Integers are used to store whole numbers without decimal points. For example, 42. Integers are commonly used for counting, indexing, calculations, and storing quantities such as age, number of students, or inventory counts. The second data type is float, represented as float. Float. Floats are used to store decimal values. For example, 3.14159. Floats are extremely important in scientific and pharmaceutical calculations where precision is required. Examples include body temperature, body weight, pH values, and drug concentrations. The third data type is string, represented as str. Strings are used to store text information. For example, Python. String can contain name, addresses, medicine names, hospital names, and many other forms of textual data. They are among the most frequently used data types in programming. The fourth data type is Boolean, represented as bool. Boolean values can have only two possible states, true or false. Booleans are used in decision making and logical operations. They help programs determine which actions should be performed based on specific conditions. You may also notice that all four of these data types are marked as immutable. This means that once a value is created, Python does not directly modify it in memory. Instead, a new object is created whenever a change is required. As beginner, you do not need to worry too much about immutability right now. As you progress in Python, you will learn more about this concept. In today's lecture, we learned what variables are and how they store data, how Python uses different data types to represent different kinds of information, integer data types for whole numbers, float data types for decimal numbers, string data types for text, Boolean data type for true and false values, logical operations such as and, or, not, type conversion using functions such as int curve bracket, str curve bracket, and bool curve bracket. These concepts are essential because they form the building blocks for all future Python programming topics. Take some time to practice creating variables and experimenting with different data types on your own. The more you practice, the more comfortable you will become with Python programming. In our lecture, we will learn about input and output operations in Python, where we will interact with users using the input and print functions and build more interactive programs. Thank you for watching. If you find this lecture helpful, please subscribe to Dr. ND's Knowledge Hub. Share this video with your friends and continue learning with us. See you in the next lecture. Happy coding.